Well, hello everyone, and welcome back to Adrian's Digital Basement. Back in 1981, IBM released the IBM PC 5150, and it started the whole PC revolution, as in the IBM PC revolution. The computer was aimed at the business market, but it sold pretty well into the home market as well. And because of the fact that it wasn't really designed to be just a personal computer for use in the home, it was pretty expensive. A version of the 5150 with 256K and a CGA monitor was about $6,000, and that's in 1981 dollars, about $14,000 in today's money. For your hard-earned cash, you got, well, a PC. We all know the specs of this thing, 4.77 megahertz. The XT after this just basically improved on this ever so slightly, but ultimately, it soon turned out that performance wasn't super great with the 8088 processor, and people were looking for more. It was just 3 years later that IBM released the IBM PC 5170, a 286 machine running at a whopping 6 megahertz. And while that megahertz speed is not a huge improvement, the actual performance improvement was pretty dramatic due to the efficiencies of the 286 processor used in this. So imagine you as a consumer if you forked over $14,000 equivalent of your hard-earned cash for this machine, and it was just 3 years later that it was already, well, obsolete. Opening up magazines and reading about the performance of the 5170, about how much faster it was than your super expensive machine, it was like rubbing salt in the wound. So that brings us to the focus of this video. I want to talk about this thing here, which is the Breakthru 286. And this was one of many processor upgrade cards available for the original PC and the XT and all the clones as well. And this card, when installed into the system, upgrades this thing from the paltry 4.77 megahertz all the way to an 8 megahertz 286. So in this video, I want to take a closer look at this accelerator. I want to see if it even works. I don't know, it was given to me in an unknown condition. And if it does actually work, let's see if the performance that this thing gives is actually even somewhat equivalent to what you can get on an actual 286. So without further ado, let's get right to it. So this is it, the Breakthru 286. This little unassuming ISA card on its own might not seem like something particularly interesting, but we have space here for a 286 processor, and it's one of these flip chip variants, and unfortunately I'm missing the metal cover that goes on top of this, so I can't properly install this, but we're gonna get around that for this video. We can see a 16 megahertz crystal oscillator up here, which indicates that this thing would be running at 8 megahertz. And we can look at the AMD 8286 here, and it has a -8, so this is an 8 megahertz variant. We have room on here for an 8287 Mathco processor. We have 3 8K SRAM chips here, and this is obviously going to be used for some type of caching. You can see the jumper up here, it says cache on it. I'm not totally sure what this cache is exactly, but the 8-bit bus on an XT really hampers the performance of a 286. So almost certainly this is going to buffer some amount of code in here, like maybe the ROM BIOS code, to help speed that up dramatically. Looks like you can remove the crystal oscillators, so potentially they sold different versions of this that ran at different speeds, and it's probably decoupled from the speed of the processor that's on the motherboard. These 373 chips that are on here are all latch ICs, almost certainly used to buffer the 16-bit processor access to the 8-bit system. And then all these PALs here are condensing a whole bunch of TTL logic down to something that will make this board really small and compact. We have a couple jumpers here. This one's labeled F and S, so I assume slow and fast. And then 5 megahertz and 8 megahertz jumper, and oddly enough, the jumper is not even installed on there, so I'm not sure what happens when you don't have it installed at all. The board is made in the USA, don't know the name of the company that made it. On the back side here, this might be the company name, PCSG Incorporated, 1986. So that gives us a time frame from when this board was actually made. Now for interfacing this to your XT, you don't just plug it into an 8-bit slot. Obviously there's a bunch of connections there, so it does communicate to the system through that. But you also have this pin header here, which goes to a ribbon cable, which I happen to have, luckily, because if this is lost, it makes using this a lot harder. This 40-pin ribbon cable goes to the CPU socket on the motherboard. So you actually remove the 8088, and this card interfaces the 286 directly to the motherboard. And that's necessary because on the PC and on the XT, the ISA bus is typically isolated with bus transceivers from the rest of the system. So in order for the 286 processor on here to be able to talk to all the peripherals on the motherboard, including the entire chipset, you need to be able to go directly into the CPU socket through all the address and data lines. There's one other little accessory that I got with this, and it's the Breakthru 286 blanking plug for 8087 socket. Must be installed in the PC motherboard. And all this does is connect a few of the pins together. And I think this is necessary to allow the system to know that a math coprocessor is available on the bus with the CPU. It's just that it's not going to be on the motherboard. It's actually going to be installed on here because it's an 8287, most likely. And it's going to be running at a faster speed than the one on the motherboard would. And the one final thing you might notice about this card is I'm missing the slot bracket. It would have had just a regular PC slot bracket, but it's been removed for some reason, and I'll just have to see if I can find another one that works for it, or 3D print one potentially. So that's the actual physical card of the Breakthru 286. Let me go do a little bit of hunting online and see if I can find any articles or information, maybe an advertisement about this card, because I certainly like to know a little bit more about it, because honestly, I've never heard of this card. I've never heard of this company that makes it, PCSG Incorporated. So let me see what I can go find. Okay, I did a little bit of searching, and here we are on archive.org and PC Magazine from March 29, 1988. And right here on page 10, so pretty early in the magazine, we have a full 2-page spread for this particular product from PCSG. It's hard to read the logo here, but I think it's Personal Computer Support Group. I think that's what this is, out of Dallas, Texas. Don't take our word for it. Use either Breakthru Speed Up Board for 60 days, and if you're not totally satisfied, simply return it for a full refund. And as I was alluding to in the intro, you think you need an AT? Make your IBM PC faster than an AT in just 5 minutes. Now, even though this board I have here is from 1986, it looks like they came out with a 12 megahertz version in 1987 here, and it was $600. And from what I can tell, that was the launch price of this 8 megahertz version in 1986 when it came out. And at least at the time of this ad, we can see here that the 8 megahertz version I have here had reduced in price to just $400. And I can't quite read what the benchmarks they're comparing here are, but it looks like the bigger bars are better here, and the 12 megahertz version simply trumps all these other accelerators that existed. So yes, Microsoft made one as well, the Mach 10. I happen to have one of those. I want to demo that at some point in the future. Unlike this board, which simply has this cache memory, the Mach 10 actually has RAM expansion right on it. I think it can go to 1.5 megabytes of full 16-bit memory on the accelerator versus just the 640K you're stuck with when you have this board. We have a couple quotes at the top here. The 12 megahertz Breakthru Speed Up Board is the fastest of those tested, but not the most expensive. On a $1 per horsepower basis, it could be called the cheapest boost available for an XT. This particular card also comes with a piece of software called Lightning here, and it looks like it's something you can actually buy separately for $90, but it comes with your Breakthru. It appears to be a disk caching tool, kind of like Smart Drive, but it looks like it actually will work on XT class computers. According to the copy text here, it says this new board has a clock speed cranked up from 8 to 12 megahertz for speeds up to 10.2 times faster than an IBM PC, and it's 50% faster than an 8 megahertz AT, and up to a whopping 1,000% faster than a regular PC. Isn't 10 times faster the same thing as 1,000 times faster, and they're like saying the same thing twice? The Breakthru 286 replaced the CPU of your PC or XT with a 286 microprocessor that is faster than the one found in the AT, has a math coprocessor slot for numeric intensive applications, and a 16K cache memory provides zero wait state access to the most recently used code and data. Speed switching software allows you to drop to a lower speed on the fly for timing sensitive applications. All existing RAM, hardware, and peripheral cards can be used without software modification. These boards are the best. The best, everyone. Yeah, they're the best. There are several other boards on the speed up market, and we at PCSG have compared them all. Yeah, that's impartial if you do the comparing. There's simply no comparison. Many cards offer only a marginal speed up in spite of their claims, and others are just poorly engineered. We're really excited about these products. PCSG makes the unabashed statement that the Breakthru 286 represents more advanced technology than that of Orchid and Quadram and PC Technologies and Phoenix. We could go on. That's pretty hilarious. But you know what? Maybe if this card works and we plug it into the system, we will see some dramatic speed improvements. I'm skeptical about 10 times faster, although that's talking about the 12 megahertz version and this is the 8 meg version. Although, maybe we can swap out this crystal and actually run a 12 megahertz processor on here, and maybe there's no other difference on the board. None of these other chips need to change. That might be something we'll have to try. Now skipping ahead just to the next 2-page spread shows this Lucid 3D thing. They're still talking about this spreadsheet, and we can see that it's from the same company here, PCSG. It's hard for me to say that quickly. Makers of Lightning. So they make that caching software, and I guess they also make this spreadsheet program, and they're probably saying they should use it with the Breakthru. Although in 1986 we developed the Breakthru accelerator board that blew everyone else out of the water, and later we topped ourselves with a 12 megahertz version. And now in 1987, those who have worked with Lucid 3D tell us, you have done it again. This is software everyone should have. Wow. Has anyone ever heard of Lucid 3D? I don't think so. I think it kind of died. Looks like you can do multiple windows. That's kind of cool. And I don't know what year this came out, 1987, I suppose. Now looking ahead in the magazine here, it doesn't look like we have the word Breakthru again. We just have lots of references to 286 machines. And while we're here, let's take a look at some of these prices here. So remember, this is 1988, an 8 megahertz 8287 Mathco processor, $251. Ouch. Now looking over at the same ad here, we can see that they're selling computers as well, complete computers. This is a 10 megahertz 286 system. It actually comes with a 40 meg hard drive and a 1.2 megabyte floppy drive, comes with a TTL monitor, monochrome that is, and 512K of RAM. It's not a full 640K, but it has a case and all the other stuff, and it's $1,400. So you can see that putting an accelerator like this into your XT is still good from a value proposition standpoint if you can actually get the good performance out of the system that this thing promises. And what I'm not too sure about is if you have your old IBM PC 5150 made by IBM, you know, big iron, are people going to make fun of you if you replace that thing with a clone? Was there some kind of social pressure to actually buy a PC 5170, which I'm sure is way more expensive, even in 1988, than the $1,399 price that's shown here for this 286 clone system? Now these magazines are absolutely filled with these ads showing all these computers, and potentially so much cheaper than you would have to pay if you're actually getting a PC from IBM. Check out this blatant ripoff of the PC 5170, 12 megahertz for only $999. I don't think this comes with a hard drive, so that's probably why it's cheaper than that other system. Yeah, if you want to add the 40 meg hard drive, it ends up being the same price, but you're actually getting a little bit more performance out of this with 12 megahertz. And it looks like you can actually get the base computer without the monitor or video card, because you don't need those. You actually have those already from your XT. And this thing does come with a full 640K of RAM. So the value proposition of this card is still there. Remember, this is only $400 for the 8 megahertz version, and it was $600 for the 12 megahertz version. But if you are willing to splash out that extra $300 in cash, you are going to get most likely a faster system with a 1.2 meg floppy drive versus your old XT system, plus those golden 16-bit ISA slots if you want to add VGA and other cards like that. Now, there's one thing I'm noticing looking around at the ads in the back of the magazine here. It doesn't seem like anyone's actually selling motherboards. Lots of add-on boards, including accelerators and stuff, and video cards and printers and various things like that, but no motherboards, and I don't really get why that is. Now, you definitely could buy just a bare motherboard and add the RAM to it, and that would allow you, at least if you had a PC XT, because it had normal slot spacing, to upgrade that computer to a full 286. And with that motherboard, you're breaking through all those 8-bit barriers you have on the XT, like the 8-bit slots and the 8-bit RAM. You're having those sweet 16-bit slots. That mean video cards like VGA cards are an easy upgrade away, and 16-bit memory plus up to 16 megabytes of RAM right on the motherboard. Well, maybe not on the motherboard, but with add-on cards. Typically, those clone motherboards could only go up to 1 megabyte, although some could do 4 megabytes. Now, fortunately, if you just had the IBM PC 5150, it had 5 slots, the slot spacing was not normal. Well, it was normal for when it came out, but by the time the XT came out, everyone copied that slot spacing. So all the clone motherboards were using the XT slot spacing. In fact, even motherboards today use the same exact slot spacing that we used when the original PC XT came out. But people with the original PC were stuck high and dry unless someone made a motherboard that had that weird slot spacing. But I guess when we looked at that one ad, the entire bare bones system with a case, power supply, 1.2 meg floppy drive, motherboard, RAM, all that stuff, it really wasn't that expensive. I think prices were really coming down on those as well. And I think most people with the PC XTs, if they didn't go with the option of the accelerator card, they just simply threw the machine away. Now, when it comes to the technical specifications of this card, thankfully the community has come through and they preserved both the manual and the software for it, which seems like that's definitely necessary. So we can peruse through this and just see what this card's all about. Looks like installation of the card is as simple as we theorized. Just remove the cover of your computer, locate the 8088 processor, remove it, and if you have the Mathco processor, you gotta pull that out as well. You gotta stick the dummy plug into the motherboard, You got to set the cache memory jumpers on the Breakthru board. There are a few different configurations for it depending on how much RAM you have on the motherboard. Plug in your coprocessor if you have one. Install the cable that goes into the motherboard and the Breakthru card into the computer. And then of course you put the cover on and you're good to go. Your computer is now upgraded. Installation of this board, especially getting the CPU out and putting this thing in, making sure you don't bend any pins, it's a little tricky, I guess I'm going to say. But I think it's something that, with enough patience, it's something you could definitely do. And I think for a regular consumer, the idea of taking the entire computer apart, taking the motherboard out, that is way more fiddly and more difficult than installing a product like this. Now here in this section, it talks about the cache configuration for the card. So it can cache up to 640K of memory, and it can also cache the BIOS ROM. That should offer a dramatic speed up as well. And then we have a cache jumper here, which can be in a couple different positions, horizontal or vertical, and it essentially sets the cache to come on as default at power up. But I saw further down in here, there's a software utility you could use to enable or disable the cache and also change the speed of the card with software control. There's also the jumper on the board here for 5 or 8 megahertz, and that has to do specifically with the 8287. When Intel released the 8287, they could only run at 5 megahertz maximum, so they typically ran at an asynchronous speed versus the CPU, so you didn't get as much performance. But later 287s that came out could run at, I don't know, up to 12 megahertz, I suppose, and I think you needed to have this thing set appropriately depending on which 287 you purchased. I also read in here somewhere that this F and S jumper here on this has to do with whether you're using a Turbo XT motherboard, because I think the software controlled turbo function on those motherboards can interfere with the software switching on this, and you got to set this F or S jumper appropriately. It's currently set to the S position, which is my understanding what it should be on for non-turbo 4.77 megahertz motherboards. That's all there really is to it. Now they have a little section here on, talking up their card. And there are two kinds of speed up boards, memory on board and caching. Memory on board products tend to be more expensive, and that's like the Mach 10 I talked about from Microsoft. That has memory on board. They're bulky and have compatibility issues. Yeah, the board is really big, and I think compatibility issues means to run full 286 software, you have to run special patched versions of like HiMemSys and things like that that can use that card. Caching products, on the other hand, tend to be a little slower. This is because of their quest for low cost and simpler design, with most caching boards running the clock from the system color burst at 7.14 megahertz, while the memory on boards do run at 8 megahertz. But for the Breakthru 286, we decided to build an extra value of an asynchronous clock running 8 megahertz. This called for more sophisticated circuit design to synchronize the system bus cycle and some more parts, nice and generic. But we've proved that the 10% speed bonus, it was worth it. Competitive caching boards only have 8K of cache, and it's talking about accelerators with cache memory, but the Breakthru offers double this at 16K. That means the Breakthru 286 is less likely to suffer a cache miss than the competition. More sophisticated circuit designs enable the use of fewer memory chips for this 16K. Yeah, it's using these larger 8-bit wide chips right here. And then they go on to talk about why this system is good and faster and etc, etc. And that's all there really is to it. This seems like a pretty capable little board and should offer a decent speed up. So now the question is, how do we get this thing working since I can't get this CPU into this socket? I'm missing the little cover that goes with it. Well, I have an idea for that. This particular socket appears to be made by 3M, and luckily, it uses the normal pin spacing that all the other sockets use, like this one, which is a normal PLCC socket. And you can see there, fully compatible. That means with a little bit of patience and hot air, I should be able to get the original socket out, install this one in place of it, and then I can just use one of the normal PLCC type 286s, which I happen to have a whole bunch of. So it's time to fire up the Hakko. Let me get that thing out of the board. All right, there it is. It popped out. I thought I had a couple more pins that weren't moving, but nope, looks like came out perfectly with no rip traces, and this socket actually is in okay shape as well. So if I ever have another motherboard that I need to replace one of these, I'll definitely be keeping this 3M Tex Tool part here. So as for the socket that's going in here, you see this has a flat edge there. It matches up with the flat edge there on the board. Let's just make sure all these pins are straight, because this was sitting in one of my little parts bins. Oh, there we go. It just fell right in. Easy peasy. And let's start the soldering process. I'll just do a pin on each corner just to make sure I have this thing appropriately centered. Oh, that's falling out of the board there. I have this propped up on a little screwdriver there. Yeah, I'm just going to do 2 pins. Reheat these joints while pushing down with my fingers on the entire socket. There we go, it moved ever so slightly. So now it is all the way flush against the PCB. It's all soldered into the board. Looks like it should have been there the whole time. Awesome. For the CPU, I happen to have a little selection of 286 chips here. Keep it in my little bin of CPUs. I have multiple of these Harris 20 megahertz parts. Now, these are nice because they run really cool. I do have an original AMD 12 megahertz chip here. This runs pretty toasty, so maybe it'd be a better choice to use one of these Harris chips here. Don't know if these are fakes. I got them from AliExpress. And this one here in this little bag here is a Dash 20 as well. I think I bought them from a couple different suppliers. Worried that, yeah, these were fakes or something. We'll start with this part here. If it doesn't work, we can swap it out. You just look for the corner that has the notch cut in it, which matches what's here on the board. And then we just align this and give it a good firm push. There it is, installed into the board. Almost looks like it should be there. Okay, for our experimentation, I'm not going to be using my IBM PC 5150. It doesn't really matter. The performance of this XT clone motherboard is exactly the same as the 5150 in every way. First things first, let's install the blanking plate. It has pin 1 right there. That goes to the top corner there. Just make sure this is in properly. Next out comes the 8088 processor. This is an NEC variant, but I can tell you that it is 100% Intel 8088 compatible. Looking at the jumpers over here, we are caching 640K of memory. The ROM BIOS is not cached, and I can't remember if the cache is enabled or disabled there with it in that configuration, but that's how it was when I got it, so we'll just leave it like that. Over here, it's set to S, which is the slow setting, which is appropriate for this 4.77 megahertz board, and we don't have a math coprocessor anyway, so it doesn't really matter. Although this is currently set to, I guess, nothing. I suppose if there's no math coprocessor, it doesn't matter. A couple of these pins are bent, so we'll just try to straighten these out. And we'll just connect up the ribbon cable like so. And we just carefully plug this into the motherboard. We have a power supply ready to go to power this board up. This is sitting on a couple of mouse pads, see that, just so it doesn't short out on there. This can, I guess, just plug into any of these slots, so we'll just pop it in right there. We'll use this VTech CGA card just for fun. I've talked about this on the channel a bunch of times. It's got Plantronics compatibility plus CGA and monochrome all in one. The keyboard's hooked up. It's hooked up to the RGB to HDMI. We should be ready to see if this thing powers up. I'm not going to plug in any peripherals yet. Let's just see if we get video output. Here we go. Oh, it's freaking working. Now this, the BIOS here thinks it's an 8088, but the non-turbo BIOS here that I'm using, this is the PC Turbo BIOS, it does not understand that a 286 could be installed in this motherboard. Nope, it does not. But what's great is this card is freaking working, and no bootable device. Press any key to try again, and let's try the XT IDE. Wow, this is freaking awesome. This works. It also tells us that the Harris CPU is actually working. And the interesting thing is I bought maybe 5 of those, and I've used them in other things, and they absolutely do work, and they run at a really cool temperature. So I don't know if they're actually 20 megahertz parts or not, but what I can tell you is that unlike the original 8088 from Intel or the AMD part, they run really cool, which is very indicative of it being an actual Harris part. For all we know though, it might only be like a 16 megahertz part or even a 12 megahertz part, but that's okay. It's actually working. Now here's a problem. It's trying to run HiMemSys, which of course does work on a 286, and it hung. And that's because, of course, this thing doesn't have any high memory, so it doesn't even matter. We don't need to run HiMemSys. It's not going to give us any benefits whatsoever. So I'm just going to skip over that. And let's edit the configs this, and we'll get rid of the stuff that's not going to work on this particular machine. Okay, everything else looks completely fine in here, so we'll just exit out. And let's remove a few things from the auto exec here. Obviously, we don't have a Cyrix 46 in here. I was testing something there. Smart drive is not going to work, so we need to take that out. We can leave DOS key, and I'm going to take away this keyboard repeat rate thing. That doesn't work on XTs, and I think we're good to go. So let's reboot this computer here, and I guess we should run some benchmarks. Now, what I did not do is run some benchmarks ahead of time, but that's no problem. All we have to do is just pop this cable out here and stick the original CPU back in, and this computer is back to its original 4.77 megahertz. Okay, here's check it. Let's see what this identifies when it comes to the CPU. 8286 XT machine, and that is correct. What it means by XT machine is it's missing the additional IRQ controller, which is cascaded off the main one, and it's also missing the additional DMA controller, which is cascaded. Those give additional DMAs and IRQs that are unique to the 286 and up machines, and it's part of the 16-bit ISA slots. So this can detect that because I think those IO ports are missing, and a 286 XT machine is a very valid configuration. The Tandy 1000 TL comes to mind as one of these machines. It had 8-bit slots, it had 8-bit everything as far as I'm aware, but it had a 286 processor. I think it might have had 16-bit memory, which would have given it the speed up that this thing currently does not have because of the way the accelerator works. Well, let's check out benchmarks here, starting with check it. It detects it as 8 megahertz. Very interesting, isn't it? 1280 dry stones. I couldn't tell you what an XT is. I'll need to write this down so we can get a little bit of a comparison going. But what I know for sure is that if this were running at the stock 4.77 megahertz, we would be running at 1.0 times an XT and 1.0 times an XT for the CPU and the math respectively. So this right away gave us a pretty substantial bump in performance. And that's before we've even adjusted to see if the cache is running properly or the BIOS caching is enabled. Next up, let's try this MIPS utility here. It actually has the IBM PC performance metrics there, and definitely would show a 1.0 for IBM PC 4.7 megahertz under that column there. And we're actually outperforming the IBM AT at 8 megahertz. Wow, for those first two at least. And then for memory to memory, a bit lower. And register to register is also a little bit faster. I mean, that's very shocking to me. I'm really surprised that at least in this benchmark, it is performing as well as an IBM PC AT. Wow. And according to this benchmark, if you look at that first column there, overall, we are 4.4 times faster than an original PC XT. And if we ran this with the regular CPU, it would show 1.0 in that column. Obviously at 386 there, that compact 386 completely blows this thing out of the water. But for a card that was only $600 and then the next year it was only $400, pretty impressive. Now, if we run speed 600, the CPU speed should be pretty good, but the video speed is going to take a relative hit. And indeed, the CPU speed is 11.15 megahertz. That is pretty amazing, to be honest. I'm pretty sure on an IBM PC 5150 running 8 megahertz, you get about 9 megahertz in this particular benchmark as well. That's really, really impressive to me. Very impressive. Now, the video speed, on the other hand, well, that's going to be pretty slow. Now, if we put a CGA card into a PC AT, even though it's using 8 bits on the AT because it's an 8-bit card, the bus on the AT is running 8 megahertz and the bus on this is running at 4.7. So that is going to be quite a bit slower on this than it would be on the AT. Probably going to get more like 700 characters per millisecond on the AT versus this 413. All right, so I'm super curious to see if this thing can run at 12 megahertz. So I have a 24 megahertz crystal here. Let's remove this 16 megahertz crystal here and pop in this 24 megahertz one. This is from my favorite 286 board. There it is. Now, I'm kind of skeptical if this is actually going to work or not, but let's see what happens. It initialized the system. Is it that easy? Is us overclocking this card that easy as just simply changing out that crystal? I actually have a crystal here that's 24.57 megahertz. And if we pop that on, we're actually going to get even more of an overclock here. So let's try speed 600 and let's see if this works. Kind of surprised they charged an extra $200 just to get the faster crystal and then of course the faster CPU. And look at that. we're running at 12 megahertz and the CPU speed is reported as 15.75. Before with Speed 600, we were getting 11.16 in this benchmark. Oh no, I think it just froze. Oh no, I thought it froze. Interesting, it looked like it froze there, but it didn't actually freeze. Now they claimed in that ad that this in 12 megahertz was 10 times faster than the original XT. And you know, in this benchmark here, 4.17, 5.61, running MIPS here, maybe the integer instructions was their relative comparison because now we're getting 10 times faster. We were getting 7.09 times faster before. And of course, in register to register copy, we're getting 11 times faster. And that really comes down to the fact that the 286 is so much more efficient at some of those instructions, especially stuff like divides and other register stuff versus the 8088. An overall performance, though, compared to the original 4.77 megahertz machine of 5.91, and that was versus 4.4, by simply swapping the chip and the crystal oscillator. And versus the IBM PC AT there at 8 megahertz, we're getting 1.43 times the performance with this benchmark alone. That's pretty impressive. Well, since this thing seems to handle the overclock okay, let's go to this 24 and change megahertz crystal here, which should boost this up to about 12.3, 12.25 megahertz. So a slight overclock compared to this little crystal down here. I kind of can't believe I'm overclocking a processor upgrade board like this, and it seems to be working. It's pretty surprising. Now remember I mentioned that the ISA bus is still running at the slow 4.77 megahertz on this machine, and that is a real bottleneck. Changing this only affects the CPU speed on the card. It's asynchronous to the rest of the system. It's using those latches to basically buffer all the stuff that's happening on the card from what's happening on the motherboard. The clock speed going to the cards is coming from the motherboard itself, so that's why there's no actual speed up from changing this crystal here. So there it is, 12.322 megahertz on an XT with an effective speed of 16.02. I'm frankly shocked. This is definitely faster than my 5170 that's sitting over here. And that machine's overclocked as well to around 8.3 megahertz if I recall. And it's not even 100% stable. Occasionally when I power that up, it has a weird error that I have to power cycle it a couple times and then the system will boot up and then it runs fine after that. This thing is absolutely flying though compared to that thing. They said this was the best car on the market, and it's not like I've compared them all, but I'm really mighty impressed here. I'm mighty impressed. Now, just doing a DIR here goes so much faster, and now it's counting up the free space, and this normally takes a long time, and that was quick. I'm amazed. This is so much faster, really is. Okay, so I was gonna check the jumpers. This absolutely is not that hot, the CPU. It's just warm to the touch. I just checked the manual, and when this is in the horizontal position, this jumper here for cache, that means the cache is enabled at power up. But what's not enabled is the ROM BIOS cache. Let's try turning that on. I don't know why that's not on. And let's see if that gives us a little bit of an improvement. The system is posting. That's a really good sign. So the CGA BIOS is handled by the motherboard BIOS right here, and that means that caching it through the cache memory chips on here actually should yield even further improvements. Now, when we ran the benchmark in Speed 600, the number we saw there won't change because that's its direct memory write. But there is a video benchmark in here which should show us the BIOS speed. I think if we go to video here, yeah, BIOS video speed on CGA, 1700 characters per second. I'm going to write that down real quick, 1723 and 21790. The bottom number there won't change if we change that jumper, but I think that top number, 1723, should actually slow down considerably when the BIOS itself is not cached. Okay, jumper is off. Let's see what difference that makes, if any. Might be makes no difference. And it absolutely made a difference. On the last run, we got 1723 characters per second, and now 968. So almost double the performance of the BIOS screen routines simply by enabling the cache. And then anything else that uses a BIOS routine will get a similar speed up, probably double the speed. So whoever was using this card before definitely left some performance on the table by leaving that jumper off. So let me copy the software for this onto this card so we can test out changing the speed on the fly, stuff like that. All right, the Breakthru utilities are here on the D drive. It looks like we have several different programs to run here. In the manual, it mentioned the BSS utility allows you to set the cache and some other stuff. And then I think it's lightning.sys, which is strangely only 216 bytes, although maybe it's the L.com that goes with it that does the disk caching. Looks like we have a couple utilities on here. There's one called test 286. Let's run that and just see what that says. Breakthru diagnostics, type 2 board. The following disk tests destroy the contents of the last track on the diskette in the drive A. If more than 20K freeze on the disk, any data will be damaged. If you want to play it safe, blah, blah, blah. It needs to access the floppy drive. I don't even have a disk drive connected, so I don't think that's really going to work. Yeah, cache test reports 10, cache map 9F. Who knows what that means? We have a little inventory program here. It says XT clone with a BIOS date of 2017. I bet you it's surprised that it has such a new date, but it probably just copied that right out of the BIOS ROM. 6.22, one floppy drive, one hard drive. Well, we don't have a floppy drive, but it doesn't really know that. One game port, oh really? Primary display is CGA and motherboard coprocessor switch is set. And the motherboard coprocessor switch is not set and the coprocessor is absent. DOS report 632 bytes total with 531 free. Interesting, there's a program called dump BIOS. What does that do exactly? Dump BIOS.bat. Ooh, okay. Let's look at that again with VI here. So it's using debug to, I guess, save your BIOS to the hard drive? I wonder why it does that. What's the point of that? Looks like it was using debug.inp to actually input these commands to debug. And yeah, it's just making a copy of the BIOS ROM on your motherboard into another location in memory, and then it's just saving that to disk. Interesting, I don't know why that's necessary. All right, let's run the breakthru command here. What does this do exactly? Breakthru bss.sys is not installed. Let's see what kind of help commands are available. Slows down access of drives A and C. It's possible that floppy drives don't work without a little bit of a slowdown, and this routine here will help make that happen. And it can access the drives normally. It can unload the breakthru program. It can turn your caching on and off. It can also assign some hotkeys for switching the cache mode on the fly. So what I do notice, there's no actual way to slow down the CPU. All it can do is turn off the cache, which will have an effect of slowing down the CPU, but it's not going to be as dramatic as slowing down the clock speed. And let's look at this L.com. This is Lightning. Lightning is speeding up drives A and B. Total RAM in use, 60 kilobytes. Oh, I thought this was going to speed up the hard drive access too, but that does not appear to be the case. Unless it can also do that. You can write protect the drive. That's interesting. I'm pretty surprised about that. You can turn that off and on. You can look at your statistics. So I guess it's a caching algorithm for your disk drives. And it's using those 60 kilobytes of main memory to just speed up drive access, probably eliminate a whole bunch of crashing of the heads. Very useful if you have a dual disk drive system with no hard drive and you're booting DOS off one disk. You can run this to just eliminate a whole bunch of that thrashing you always got with programs that didn't use the floppy drives very efficiently, at least. I'm really curious if anyone's ever used them like this back in the day, because I don't think I've ever heard of a floppy drive cache utility like this. Pretty cool. All right, so we're going to edit the config sys, and I'm going to add that bss.sys into here. And I think there are some extra parameters you can apply to it, but we're just going to leave that with stock and reboot the system here. And I'm very curious to see what the performance of the machine is like when we turn off the caching entirely. There it is. 1988 Personal Computer Support Group, Resident Breakthru 286 Speed Switch program. So it looks like you have to use the device driver and this program to change the performance here. So let's turn off the caching. Breakthru, cache off. Caching was not on. Let's see what we're getting with the performance on Speed 600. Whoa, this feels really slow. I wonder if loading that program actually disabled the cache, even though the jumpers are set to keep it on at power up. I have a feeling, yeah, it's off now. Oh, look how slow this is. Wow, so it thinks the CPU clock's running at 6.6 megahertz, and overall the performance is, well, really, really slow, 2.31. All right, let's try check it here, and let's see if we're back to like PCXT speeds or close to it. Yeah, here it thinks we're running at almost 9 megahertz. Oh, 344 dry stones. I think this is worse than the PCXT, actually. Wait, no, it's 1.0 times PCXT? That's kind of amazing how it's able to hit that perfectly, even with this overclocked board here running at over 12 megahertz. And let's give MIPS a try here, and let's see if we get 1.0. No, we don't, of course. And that's because the 286 is still the processor that's running here. And even when you slow it down artificially with whatever's happening on here, it's still fast at some of these things here, although it's not nearly as fast as it was with the cache turned on. So 1.33 times a normal XT, but some of those metrics are slower, but then some are faster just because of the 286, and we are way slower. So I think games that don't run well on a 286 are probably going to work fine with this program running here. Let's try turning the cache on. I think I have that right. Caching is now on, and let's see if that made the difference for performance here in MIPS. Yes, we are definitely back to full speed again. There's that 10.75 for integer to integer, and I think this one should be 12. Oh, it's even a little bit faster. Interesting, we have like additional performance somehow. Or maybe I didn't run this with the BIOS caching enabled. I think I didn't. So maybe that's why it's even faster than it was. 6.13 times. Amazing. Speed 600 though, I think it should be around 16.0, which is what we saw last time. And I don't think this relies on the BIOS routines at all. So, okay, yeah, 16.0. Maybe same thing. All right, I want to try a couple games here. So what we're going to do is we're going to switch over from CGA over to VGA, and that just gives us, I think, a little bit of a performance boost, and also allows different graphics modes that we don't necessarily have. This Cirrus Logic card absolutely supports running on an 8-bit slot, so it's going to work in here. Now, what's not going to happen here is the BIOS caching that's still going on for the system BIOS is no longer going to speed up the video, and that's because the system BIOS handles MDA and CGA, so that is sped up, but the VGA card has its own BIOS, and that means that we don't get any of that speed improvement. Let's just see what we're getting for speed 600 though, when it comes to the video speed now. It looks like what's happening here is that bss.sys that's loading and configs this is disabling the cache on boot. And since I don't see why I'd ever want to turn off the cache, I'm just going to disable that and just switch the mode of my capture device there so it doesn't look so bad. So it seems like this utility is not required if you configure the jumpers appropriately, like they're already configured. But the utilities really only give you the option of turning the cache on and off just for a speed change if that's something you can't easily access because the card is inside a computer, unlike it is here. All right, so definitely this is way faster running here, 833 characters per millisecond. So because this is VGA here, we're actually getting a big speed up over that CGA card, more than twice as fast at the direct memory access. Anyhow, we can run some games now because I have the VGA card in here. So let's try Outrun, and I can run this in VGA mode. Now this is really quite a bit too slow to play on a regular XT, but let's see what happens here with this. I mean, this seems okay. Let me switch the mode on my capture device here. Program loading. Oh no, wait, this is still really too slow. This still seems, you know, it's playable. It is playable. I don't really know what this is like on an XT. I have to say, I don't think I've ever tried to play this on an XT. I think it's pretty terrible performance-wise, and this is pretty good. Let's try Prince of Persia, which I think runs on an XT, but it's pretty slow. We have to run games, of course, that don't require any extended memory. Since there isn't any on this system, we're stuck with just whatever's available in DOS. Wow, I'm amazed by this. This seems to be working really nicely. And of course, we'd have music and everything like that. I think what I'm gonna need to do is we're gonna have to swap back to the regular stock processor on here, and then we'll see exactly what this thing performs like, because I don't think, I think this is a lot slower when running on a regular XT. Yeah, let's just give this a try. So I'm curious on this system, if we put the original processor back in, but I leave the blank in, I leave the card in there, what's gonna happen? Looks like nothing. System still seems to be posting. Obviously we're running with the stock processor though, so we're not getting any of the performance improvements. All right, so just booting up, the system feels way slower. It's remarkable, the difference. First we'll try Outrun, and we'll run this in EGA VGA mode. Let's see how this goes. Okay, so just this transition here is much slower. Wow, yeah, like there's a lot of waiting happening here, just between screens and things like that. It's not even accessing the hard drive that much, but really seems a lot slower. Now look, this game came out in 1989, so that's really pushing the limit on a machine that came out essentially in 1981, at least the 4.77 megahertz machine here, or the performance of that. Okay, look at this. It's so bad. It is, I mean, you could just see the difference here. Wow, this is absolutely unplayable. I mean, I suppose if you had nothing else and you had a VGA or EGA card in your PC, XT or PC, you'd try to play this. This is absolutely miserable. I mean, yeah, that is not good at all. If anything demonstrates the performance improvement you get with this accelerator card, that is it. Okay, time for Prince of Persia. Let's see how this performs on an XT with VGA. Now, there's no sound card in here. We would have ad-lib sound. Hey, at least that transition is nice and smooth thanks to VGA's extensive color palette. Okay. Wow. This is like playing in slow motion. It's playable. I bet you people played it with like this, but it's very, very slow. Look at that. The game doesn't really have a super smooth frame rate, even on a super fast computer. So I'm saying that like with the 286 that we had in here with the accelerator, that's pretty much what I remember the game playing. Like maybe it's a little slower than if you had a faster computer, but this game doesn't really run at 60 frames per second no matter what you do. But this is very sluggish and it would be very difficult to play. Like I let go of the keyboard and look, it's still animating. I am super impressed with the performance that this card gives this old computer. If I had a PC 5150 that I spent a bunch of money on and I was a kid trying to play some games and that's the only computer I had and I got one of these cards, I would be so happy. This card is freaking impressive. Not to mention, I can't believe the overclock was so easy on this. I mean, it's possible we could go even beyond and maybe go to 16 megahertz. Who knows? I'm sure this chip in here can do it. It's just whether the other ICs on here can handle that. Now, what I don't know is that in 1988, when we saw the advertisement for the 12 and the 8 megahertz version, was the price difference in the CPU really $200? I have a feeling that's a bit ridiculous, and it wasn't. I'm sure the 286s weren't super cheap, but I bet you from 8 megahertz to 12 megahertz wasn't that big of a price difference. And we've basically figured out here that there's no other difference on this card other than the crystal oscillator, which is a couple $1 part, and then you got a much faster system. Now, one thing I don't know is this little ceramic flip chip thing. Maybe these in 12 megahertz speeds were kind of expensive and these PLCC plastic packages were the cheap ones. And the fact that they used this flip chip thing kind of limited their options, although you saw how easy it was to swap the socket over. And, you know, I suppose I should do another video, maybe on the second channel, where we try to push this thing absolutely to the limit and see if I can get this thing running at 16 megahertz or 20 megahertz even. Imagine that, imagine that. But anyhow, like I said, I'm really impressed by this card. It looks so unassuming and simple, and yet it packs a punch when it comes to performance improvement for old PC and PC XT. That is freaking awesome. So if you ever had one of these cards or any other accelerator for your old XT, I'd love to hear more about it. I wasn't really focused on the PC market back then. I was Apple II person and then Apple II GS and then Amiga and stuff like that. And then I only started getting into PCs around like the 486, 386 SX era. So I sort of skipped over all this really slow stuff here. But it's pretty neat to see that cards like this existed and they offered some mighty fast performance for the old system that came out in 1981. If you enjoyed this video, I'd appreciate a thumbs up, but if you didn't, you know what to do. Huge thanks to my patrons. Their names are scrolling beside the screen over here. They make it possible I do this full time. And when you're watching this video, I am going to be at VCF Midwest in Chicago. So hopefully you're there and you can say hello to me. And if not, maybe I'll see you at another conference at some point in the future. I guess that is going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.